All right, so in this video, we're going to learn how to graph a hyperbola. So in the last couple of videos, we did circles, we did ellipses. Now, hyperbola is kind of the opposite because circles and ellipses, they come together. They form, a circle or an oval. Well, now a hyperbola is, instead of it coming together, the kind of two parabolas, they're going to be going in opposite directions of each other. So for each point on a hyperbola, the absolute value of the difference of the distances from two fixed points is constant. And these fixed points are called the foci. Okay, so the absolute value of the difference of these distances is constant. The line passing through the focus is the transverse axis. So you can see that labeled up here. It's the transverse axis going through the foci. The point located on the transverse axis halfway between the foci is the center. So we still do have a center that it's bending away from instead of bending into. So the transverse axis intersects the hyperbola at 2 points called the vertices. So again, we also have vertices on this one, just like we did on the ellipse. And every hyperbola has two asymptotes. I forgot the P there. Asymptotes that intersect at the center of the hyperbola. So you can see on both these graphs, either horizontal or vertical, there are these asymptotes going across, and you can see that there's a square. This is actually an easy way to build these two kind of limit lines, these asymptotes. You can build the square very easily, and then if you see, it goes right through the corners of the square. So it's actually a really easy way to graph those, especially if you're doing this on paper. So if we take a look at these before I scooch to the next page here, we have our either horizontal or vertical. And if you notice, these are very similar equations to what we were doing for ellipse. We have x minus h squared and y minus k squared. We have a squared and b squared. Instead of plus, though, we have minus. Now, the way I remember this is the plus. Whenever I see plus, it's going to be either a circle or an ellipse because the two parabola are coming together. So when I see minus, I automatically know that it's a hyperbola because they're going apart. Okay, so that's kind of my easy way of remembering that. Now, if you remember from ellipses, the x minus h squared and the y minus k squared did not move. It was the a and the b that moved. But now with a hyperbola, the a and the b do not move. It's the x or the y that move. So it's the one being subtracted that actually tells you is it horizontal or vertical. So if y minus k squared is being subtracted, then it's a horizontal. If x minus h squared is being subtracted, then it's vertical. Okay. Or you could even think of, which one's positive, if that helps you more. The positive, if x is the positive one, then it's horizontal because it's going right and left. If the y is positive, then it's vertical because it's going up and down. That's another way of thinking of that. You can also look at the a squared because the a squared is always the biggest one. So whichever the biggest one is underneath or over, is going to be the direction that it's going, either horizontal or vertical, is x or y. So a couple different ways that you can kind of think of that. So very similar to the ellipse, we have kind of these rules that go along with it. So we have a center HK. Both of those are the same. The vertice is h plus or minus a, and then k, because I'm just going to go to the right or the left, but k is going to stay the same. I'm not going up or down. I'm just going right or left from the center. The foci, that's that c, so it's h plus or minus c with a k, because we go just a little bit farther than the vertices on that one. And to find c, we can use Pythagorean theorem, a squared plus b squared equals c squared. Our transverse axis is y equals k, so whatever k is, it's just a horizontal line right across here, if it's a horizontal hyperbola. And then we have our asymptotes, which we do have this line for, although I do find it much easier to graph the box. So I can kind of show you what I mean by that in just a little bit. But you can, of course, graph the line using this formula as well. So if you take a look at the vertical one, really the only thing that changes is now instead of going right and left, we're going up and down. So now the h stays in both the vertices and the foci, and we're going to go up or down by a factor of a or a factor of c. Excuse me. The transverse axis is now x equals h because it's a vertical line instead of a horizontal line. And now our asymptote is just a little bit different because it was b over a, now it's a over b. So it changes slightly based on the direction of the hyperbola. Okay, so let's go ahead and keep moving here. So we're going to note the following features of the hyperbola shown above. So of the two that we just looked at. The distance between the center and each vertex is a. So the center and the vertex is a. The distance between the center and each foci is c. The asymptote intersect each other at the center, which is hk, so they always intersect at the center. When the transverse axis is horizontal, the slopes of the asymptote are b over a and negative b over a, so you have two of them, right? They're going in opposite kind of directions there. When the transverse axis is vertical, the slopes of the asymptotes are a over b and negative a over b. So we kind of saw that when we take a look at this and they flipped over. Also noticing the rectangle appearing in each figure. Two sides of the rectangle are located a units from the center of the hyperbola. Those pass through the vertices. And the other sides of the rectangle are located b units from the center of the hyperbola. So the asymptote of the hyperbola passed through the corners of the rectangle. So if you create the little box, then you can very quickly create the asymptotes. Now you're not going to have to do that on Alex. There is actually an easier method. So I'll show you. If you're doing this on paper, you want to kind of create the whole box so that you can cross your lines and have the whole thing. But on Alex, it actually is quite a bit easier. So will this be vertical or horizontal? Well, looking at this, since I have a positive x or negative y, whichever helps you remember, but since positive x, that means I'm going to have a horizontal. So y is being subtracted, or you could say x is the positive, x squared is the positive term. Either way, that works. So now my center, well, I have h and k, since they're both negative, that's the way that the formula was supposed to be, right? So it's h and k. So just 4 and 2. And then I have a squared and b squared, so I'm going to take the square root of each of these. So square root of 16 is 4, square root of 9 is 3. So a is 4 and b is 9. Sorry, b is 3 because I have to take the square root. So now to do the vertice, and I brought this over here just so we could see it. You should still be able to see it on your paper, but I had to break this up a little bit so that it wasn't too much on one page. So I can do h plus or minus a and then k. So 2 is going to stay 2 for both of these, but I'm going to take h and I'm going to add a to it. So it's going to be 4 plus 4, and it's going to be 4 minus 4 for the next one. So I'm going to have 8 and 2 and 0 and 2. Those are my two vertices. So creating the rectangle. The right and left sides of the rectangle are located a equals 4 because a is 4 units from the center. So those sides pass through the vertices, right? So I can go from the vertex and I can go over 4 units, right? And I can go over 4 units left. And that's going to be where the sides of my rectangle are. The top and the bottom sides of the rectangle are b units from the center. So they are located, if I go b units from the center, and that means I want to go up and down, I'm going to go 2 plus 3 and 2 minus 3, right? So I'm going to have negative 1 and 5. So the asymptotes pass right through the corners of these rectangles. So this could definitely be very helpful if I'm doing this on paper. So I can show you. On Alex, this is all you're going to have to do. You put your center, so you have your 4, 2, and then you put one of the vertices, which also happens to be A. I can go 4 units. Now I can also go 4 units this way, and this is where I'm going to draw the part of the box. Now if I go 3 units up, this is where the corner of the box is going to be. So I can actually draw a line that's 3 units down, and then come over, and that's 4 units over this way. And I can draw a box all the way around. Now on Alex, it's a little different, but that would draw my box, and then I can just connect to those corners, and I would have the asymptotes, okay? And then you can graph your hyperbola around the asymptotes. Now on Alex, it's a little bit easier. You don't have to worry about the whole box. I only need these 3 pieces. So I'll show you on this video because I recorded it so you can see. So you'll see me graphing the center here. So there's my center, there's my A, and there's my B. I don't actually need to put these points, but they're nice references. So now I'm going to place it on the center, place it on my vertex, place it on my asymptote. And it automatically graphs it for you, and that's it. So it's a very, very nice feature. It's very easy to use on Alex. And it gives you the nice hyperbola there at the end. I can pause the video so you can see it a little longer. So it graphs the lines for you as soon as you place those 3 points. So that is all you need on Alex to graph a hyperbola. I hope that helped, and I will see you in the next video.